In order to find the inverse of a matrix, we have to use our row operations with something called an augmented matrix in order to turn it into the inverse. So first off, for two matrices to be inverses, it means when you multiply them together, so we're trying to figure out what could the inverse be. When we multiply them together, our goal is for them to cancel out and to turn into this identity matrix. So 1, 1, diagonal ones with offset zeros. So to figure out that matrix, we're going to turn this into an augmented matrix, which means we're going to put the matrix we have in first, so 2, 4, 1, and -1. And then we're going to put a little dotted line down the middle, and you'll see this a couple different ways. And on this other side, we're going to put our end goal for the matrix. So we know we want it to end up with a 1, 1, 0, 0, and those ones should always go diagonal from left to right. So now the whole process of finding the matrix, our goal is to turn the left side into the identity matrix. And to do that, we're going to use row operations. And as everything turns from the left side into the identity matrix, the right side will become the inverse. So when we're doing these row operations, the best place to start is the upper left. So in order to get that identity for the upper left, we need to turn that 2 into a 1. So in order to turn the 2 into the 1, that means we need to multiply all of that top row by 1/2. So we're going to do 1/2 times row 1. And then we're going to change only row 1. So row 2 will stay exactly the same. Row 1, multiplying everything, both sides, by 1/2. So 2 times 1/2 is 1. 4 times 1/2 is 2. 1 times 1/2 is 1/2. 0 times 1/2 is 0. So we always want to start in the top left, and we want that top left to be a 1. To get that 1, we always just use a scalar. So now the best way to work with this is we're going to kind of work in a U. So we're going to go down and around, working counterclockwise. So the next element we're going to deal with is this 1. Well, the 1, if we look where it matches in the identity, the 1 has to turn into a 0. We're not allowed to multiply a whole row by 0 because it cancel out. So to turn the 1 into a 0, this is when we use that addition and subtraction. We already have a 1 up here in row 1, so we know if we just add the opposite of that, it'll go away. So what I'm going to do is do a negative row 1, add it to row 2, and this is where I always circle what I'm doing. We're replacing row 2. So we'll write out the matrix. Our top row is going to stay the same, so I'll switch colors. We are not going to affect that 1, 2, 1/2, 0. We're changing our bottom row. So for this first spot, it'll end up being -1 plus 1. That gives us 0. For my second spot, negative row 1 plus row 2, so plus -1. That gives me a 3. For the next spot, -1/2 plus 0. That gives me -1/2. Last spot, -0 plus 1. That spot stays a 1. So notice how we're adding vertically. Multiply the top row by its number, and then we vertically add and change the next row. Okay, we're going to keep working our way around. So the next thing we want to turn is this -1, which in this case is now a -3. We want to turn that into the 1. So again, we're kind of working in a U. We start at the top left, we work around to the top. So first column's done, on to that next spot. Remember, in order to turn something into a 1, you just have to multiply by a scalar. So to turn -3 into 1, that means we need to multiply the whole second row by -1/3. So again, write out your matrix. We're only doing the second row again, so top row stays the same, 1, 2, 1/2, 0. Bottom row, so negative 1/3 times 0 is 0. Negative 1/3 times negative 3 is 1. Remember, the whole point was to turn that into a 1, so if it didn't work, we need to go back and revisit. Next row, we have negative 1/3 times negative 1/2. That's 1/6. Last row, negative 1/3 times positive 1 gives us negative 1/3. Okay, last step, our last spot we need to get is this top element. We need to turn that 2 into a 0. So again, to turn something into a 0, that's when we do this multiplication of rows. And this is why we always work after we do the 1. So if we do negative 2 times row 2, add it to row 1, and we're replacing row 1. So draw our matrix, put our dot, dot, dot in. Remember, row 2 is staying the same this time, so 0, 1, 1, 6, negative 1/3. We're changing our top row. So we have negative 2 times row 2, so negative 2 times 0 is 0, plus 1 is 1, so that spot stayed as a 1, as it should. Next one over, we have negative 2 times 1 plus 2, that is a 0, which again was the whole point, so we hope that one's right. Move on over, negative 2 times 1/6 plus 1/2. So negative 2 times 1/6 would be negative 2/6 plus 3/6 be 1/6. And negative 2 times negative 1/3 plus row 1, which is 0. Negative 2 times negative 1/3 is a positive 2/3. So now, the left side is that identity matrix, the 1, 1, 0, 0. What this right side turned into is our inverse matrix. So our answer here, our inverse matrix, is 1/6, 2/3, 1/6, negative 1/3. So essentially, to find the inverse, we want to find how we can undo the original matrix by going through this process and having this identity. We're figuring out what are the opposites, essentially, as far as matrix multiplication is concerned, in order to find that inverse.